Hello everyone, my name is Seung-Yeon Bang. I'm a student majoring in electrical and computer engineering at the University of Seoul. Today I'm going to talk about what I have learned in Cadence Full Custom IC Designer course. So this is the outline of my presentation. So in these courses I use the Cadence tool versatile to schematic and layout to design the digital circuit and perform simulation in Spectre in ADL environment. And then I verified the circuit operation in DRC and LVS. The process technology in the all implementation is 90 nanometer CMOS. So let's start with NOT gate. In each digital gate, I draw the schematic first, and then I simulate to determine the optimal PMOS width in ideal switching point. And then I move to layout and verify both DRC and LVS. And then we can check the NAND gate. You can see the NAND gate was constructed in the parallel connection in PMOS and the series connection in NMOS. So this is the schematic of NAND and layout. In contrast, the NOR gate, there are the series connection of PMOS and parallel connection in NMOS. So also schematic and layout. As you can see, as the number of input in the NAND gate increases, the individual PMOS is reduced, whereas in NOR gate, the PMOS width increases. The difference is due to the register characteristic of the NAND and NOR, the parallel and series configuration. So let's see the MUX. I designed the multiplexer in two different ways. The first is using NAND gate or transmission gate. So this is the schematic of 2-to-1 MUX. And you can see the output correctly changing based on the input signal, select signal in the simulation. Layout. And I designed the 4-to-1 MUX using 2-to-1 MUX block or transmission gate. Again, the simulation output confirm the circuit operation. So this is the layout. And I finally made the full adder circuit. To build this, I first designed the half adder and XOR gate, and then combine it to make full adder. So XOR and half adder, and combine them to make full adder. And then I extend it to make 4-bit adder subtractor. So this is my final layout of 4-bit adder and subtractor. For these courses, I gained hands-on experience in the designing digital circuit, and then I became much more confident in using the Cadence tool. In addition, I constantly upload what I have learned in my technical blog. My blog has reached over 506 views and can receive positive feedback from my readers. This made me realize the value of sharing knowledge, and then I inspired to become the semiconductor engineer to contribute the community in the future. Thank you for listening.